And so the talk today is by Dr. Ven Popov. So he got his PhD in 2020 from CMU and is currently a postdoc at the University of Zurich. He's also the winner of the 2021 Glushko Dissertation Prize. So I'm very excited to hear his talk. So Ven, you can share your slides when you're ready.
Okay, thank you for the introduction. Yeah. Thank you for the introduction and thank you for having me here. Let me see. Can you see my slides? Okay. Welcome everyone to my talk on the effect of intent on long-term memory. To start with, let's see. Oh, there we go. To start with, I would like everyone here to try to remember your last birthday. Try to recall where you were, who you were with, what you were doing, what kind of presents you received, if any. Now, probably all of you here can remember that event very well, despite the fact that I doubt any of you spent that day sitting there thinking, oh, I must remember what happens today because someone will ask me in the future and I need to remember that information. So what that illustrates is a very basic property of the episodic memory system, namely that it tends to encode all information that we actively attend to and process deeply, regardless of whether we intend to remember it for the future or not. And that brings me to today's question. Does the intent to remember actually affect long-term memory performance? And to answer this question, I will take you to the way less exciting world of memory for lists of words rather than birthdays. This question was actively investigated in the 70s and the 80s in the context of the depth of processing paradigm, in which oftentimes people would be given a list of words and they would be asked to either make a shallow judgment for each word, whether it contains a particular letter or whether it rhymes with something, or they would be asked to make a deep semantic judgment, such as evaluating whether a word is pleasant or not, etc. So here's one example that comes from Hyde and Jenkins. They had 3 different orienting tasks going from deep to shallow. But importantly, they also had 2 groups of participants. One, which is the intentional learning group, who were told, in addition to making these judgments, you have to remember the words for a subsequent memory test. Incidental group was exactly the same in terms of the word judgments, but they did not expect the test at the end. And what they found was that if the task is shallow, you see substantially better memory for the intentional learning group relative to the incidental learning group. However, if people processed all information deeply, we see very little to no difference between the intentional and incidental learning group, suggesting that as long as the information is processed deeply, it doesn't matter whether you intend to remember it or not for the future. And this is an effect that has been replicated dozens of times, and it led Craik and Tulving, along with other findings in their seminal article, to conclude that it is abundantly clear that what determines recall is not the intention to learn, rather is the kind of operations that are carried out on the items. So this is a very strong and fundamental claim about how episodic memory works. And nowadays it's widely accepted to the degree that we teach it in introductory courses on cognition and memory. So it's important to know whether that's true or not. Now, more recently, Klaus Oberauer and Oberauer Greve extended these findings to show a dissociation between long-term memory and working memory, in which, just like with the previous studies, they had people do deep processing for every word, and they had between subject manipulations of whether people expected the remember test or whether this was incidental learning. And just like previous studies, when it comes to long-term memory, they found no effect of intent. However, when it comes to working memory, they found that despite the deep processing of all items, those items that people knew they would be tested on, they had a substantially better memory for that. Now, this behavioral dissociation is interesting in and of itself, but also led Oberauer and Greve to conclude that it represents a fundamental functional distinction between working memory and long-term memory, and that namely that Working memory, we all know, is severely limited. The more items you store in it, the more interference you have among them. So intent serves as a kind of a selection mechanism. If you intend to remember something, you protect it from interference by not encoding or not binding items that you're not supposed to remember. In contrast, they argue that long-term memory, at least in its total capacity, is unlimited. And we also never know what information might be useful to remember for the future. So it makes sense for the system to evolve in a way in which, as long as you attend and process information deeply, you remember it all, regardless of the intent to remember. Now, this is a very reasonable argument. However, there's one issue with it. Even though the total capacity of long-term memory might be unlimited, we know that working memory is that long-term memory is limited in the amount of information you can store within it within any particular interval of time. We know that from presentation rate effects, primacy effect, list length effects, etc. And recently, me and Lynn Vrier proposed a theory in which in order to store information in episodic long-term memory, you have to deplete a limited resource that recovers gradually over time. So all of that to say is that long-term memory also requires some kind of selection mechanism in order to make the decision how to distribute these limited resources among learning items. So I was honestly very surprised to learn that intent doesn't matter for long-term memory. And so this was the goal of this entire project, to try to replicate all the findings and determine if and why and when intent helps or it doesn't. And if you're interested in learning more about this, everything that I'm going to talk today is written up and is available as a preprint on Psych archive. So this is not a suspense novel, so I'll give you the answer right away. It turns out that intent matters a lot for episodic memory, but we only find this within subject mixed list experiments, in which instructions to remember or not are given on an item by item basis. But for some reason, as we know from these older experiments, is that it doesn't matter in a between subject paradigm when we have separate groups of people told either to remember everything or not told anything. So that makes for a very interesting puzzle. If intent has no effect on memory, as Craik and Tulving argued, why is it that we find that the design of the experiment determines whether such an effect is observed or not? Today I'm going to, to investigate that, I've performed 10 experiments, but for the interest of time today, I'm going to focus on the first and the last experiment. In the first experiment, I'll establish the basic finding that intent matters for within subject experiments. And in the last 3 experiments, I'll show you support for what I consider to be a plausible explanation of these results. If you're interested in various alternative explanations that we've discounted, I'm happy to answer questions about those at the end. So the general method, all 10 experiments were very similar to each other. People studied 1 to 3 different lists of 30 words or word pairs. And for each word, they had to judge whether the word was larger or smaller than a football, or whether the word was larger or smaller than the other words presented on the screen. And people were also told that some of the items on the list will be tested later. And we manipulated that on an item-by-item basis by presenting the words either within a red color or a blue color as well. After the study, there was a 1-minute distraction task to clear working memory. And at the end, there was either a free recall test, a forced choice recognition, or a cubed recall, or source memory, depending on the experiment. And the important part is that with experiments that had more than one list, all lists tested only the remember items, except for the very last list, which there was a surprise test in which people were told you have to remember all items, regardless of the color that was surrounded around them. Okay, so the first experiment was very simple. As I said, people saw a list of individual words or word pairs, and immediately they knew whether they had to remember the word or not. They had to make the semantic judgments, and after the response, they had additional 3 seconds before the next word appeared. If Craik and Tulving are correct, and Oberauer and Greve, that intent doesn't matter for episodic memory, we, just like in between subject experiment, we should see that as long as these words are processed deeply, it wouldn't matter for recall whether people knew they'll be tested or not. This is exactly the opposite of what we found. So here I'm showing you the results for pairs of words or individual words and the 3 different lists. And here the blue line shows the words that people were told to remember, whereas the red line shows the words that people were told they are not going to be on the test. And it immediately jumps out that on the critical third list, where all items were tested, even though these were words for which people made deep semantic judgments, we see a fairly substantial, almost 50% recall difference between these two conditions. I was very surprised by this, first because we rarely see such huge effects, but this is exactly the opposite of what you find in exactly the same paradigm, but in which you manipulate intent between subjects. So we have yet another mixed list paradox in episodic memory, to join a few others that are there. Now, before I try to explain why we find that distinction, it's useful to look at a few other pieces of the puzzle first. One other piece concerns response times to the semantic judgments during learning. What we found in this experiment is that, so here I'm plotting size judgment RTs, that consistently across all lists and stimulus conditions, people take longer to make the semantic judgments for the remember items relative to the process only items. So it seems like people are doing some additional processing for the remember items on top of the deep processing task relative to the process only items. Now, it's very curious that actually, if you look at between subject experiments like Oberauer and Greve, they also find that the intentional learning group spends longer processing the items. However, for some reason in between subject experiments, that doesn't lead to better memory for those items, whereas it does for us. We looked at this a little bit more granularly on an item by item basis. If we look at how long it took people to study the item, and we plot subsequent memory as a function of that, here I'm showing you the study quantiles for the reaction times and free recall probability. And we see that for remember items, the longer people took to make the semantic judgments, the better memory was for that item. In contrast, for the process-only items, it didn't matter how long they spent processing it. So it seems like, particularly for remember items, people are doing some additional processing, and the extent of that processing determines how good their memory would be for that. Now, before we jump into explanations, I want to show you results from the 3 other experiments, in which the only thing that differed in these new experiments is when the remember or the don't remember cue appeared. So in the first experiment, people had additional 3 seconds after the semantic judgments. So it's possible that they did some additional processing, even deeper processing in that period that led to this substantial difference. So in experiment 2, we eliminated that time, and people saw the next word immediately after making the semantic judgments. And so if the difference between these conditions is due to additional processing during that interval, it should be eliminated. Well, it isn't. The memory for remember items is slightly reduced, but we again see fairly substantial difference between the 2 conditions. Now, one thing that's common between these 2 experiments is that people knew from the presentation of the item whether they have to remember it or not. So it's possible that for remember items, they performed the semantic judgment task more diligently. The task itself induced some kind of deeper processing. And even though we didn't see differences in accuracies on the semantic judgment task, maybe people can get away with very minimal processing to do it, and that affects memory subsequently. So in the next experiment, when the word was presented, people did not know whether they have to remember it for a later test. And only after they made the semantic judgments did they receive a cue, whether to remember or forget. So now the semantic judgment should be equivalent between the 2 conditions. Again, that made no difference whatsoever to the results. And at this point, one explanation that we considered is that even though, so this is not a remember versus forget instruction, we didn't tell people you have to forget the process on the items, but maybe they attempted to interrupt the consolidation of items that are not supposed to remember by when they saw the color blue, which means don't remember, they interrupted the consolidation of the item from working into long-term memory in order to reduce interference. So kind of to address that, from the directed forgetting literature, we know that if you delay item instruction cues, it tends to significantly reduce or eliminate directed forgetting effects. So we added a 5-second delay between the judgment and the cue. And again, that had very little effect as well. So it doesn't seem plausible that people are interrupting the consolidation of this item. So we have now, kind of as a summary of these 4 experiments, we have a really big substantial effect of intent within subject experiments, which is in stark contrast to between subject experiment. And we also know that the timing of the cue doesn't matter much. And we've also learned a couple of things from looking at the reaction times, and we know that people spend extra time processing the remember items, and that translates in better memory, not only overall across conditions, but if we look at each individual item, processing time determines the effect. Okay, so at this point you could say, well, okay, yeah, this is just a processing time effect. We know that memory is better when you spend something longer. This is not a satisfying explanation for several reasons. First, processing time is not a mechanism. The question is what is happening within this processing time. Second, from between subject experiments, we also find differences in study times, but in between subject experiments, that doesn't lead to differences in memory. So whatever mechanism is responsible somehow have to account for the distinction between these 2 types of experiments. And also processing time wouldn't explain why memory for the process-only items is so abysmal. It's 3 to 4% across all experiments. Okay, so here are some possible explanations that we can consider at this point. So as I mentioned, people might interpret the absence of remember instructions as instructions to forget the items, and that would make our experiments more like the item-wise directed forgetting paradigm. And so one explanation of direct forgetting is that people engage in active inhibition of forget item, and that is a process that takes time. I already mentioned the interrupted consolidation of process on the item. Another possibility is that this is not an affected encoding at all, but it's an affected retrieval. So since on several lists, people always recalled only the remember items, even on the surprise test after list 3, they might begin retrieving the remember items, and that generates enough output interference to prevent them from retrieving the process-only items, even if they have equivalent amounts of memory. Fourth possibility is that people engage in relational encoding of items. So they will try to relate how this particular item relates in meaning or image or rhyming to the items that they have seen before. And maybe they do that selectively only for the remember items, which boost their memory. And the final possibility is that Craik and Tulving are incorrect, that intent matters and specifically strengthens item context associations for remember items, although that by itself doesn't explain why the effect doesn't show in between subject experiments, and I'll get to that a little bit later. I won't address all of these in the rest of time. I'm happy to answer the question, but I want to address the active inhibition first, because we can address it with reaction times from experiment 1. We know that inhibition is if it exists, it's a process that takes time. There are findings in support of that. So one prediction that we could make is that if one word was a process-only item and people are trying to inhibit it, that should delay semantic judgment responses for the subsequent word, because that active inhibition process takes a certain amount of time. So in all of the previous experiments, I've looked at size judgment RTs not only as a function of instructions to the current item, but also as a function of whether the preceding item had to be processed or remembered. Now, in contrast to the active inhibition explanation, we find exactly the opposite pattern of results. In all experiments, if the preceding item was to be remembered, people spend more time making the size judgment for the current item. So this is true in all 4 different experiments. So this suggests that in contrast to active inhibition, people are actually continuing the processing of the previous remember item when the current item appears, and we don't find evidence for active inhibition if inhibition takes amount of time. So it's not active inhibition. I already mentioned that I don't think it's interrupted consolidation, because even if we delay the cue, it doesn't make a difference. In experiments 5, 6, and 7, which I'm not going to present today, we also eliminated
Is Ven's audio and video stuck for everyone?
Yes,
so
me too.
Okay, we lost you for maybe like 10 seconds.
Okay, what was the last thing I said?
You're back. I
Okay.
think you were at the beginning of the slide, yeah.
Okay, yes, so we have evidence that none of these explanations can account for the data, and I'm not going to present these experiments, but you can look them up in the paper, or I can ask questions about them. So at this point, I was very confused and trying to figure out how can we explain the distinction between these two types of lists. And here's the account that I managed to come up with. It's combining bits and pieces from models of episodic memory that we know. So we know that successful free recall depends both on item memory and item context binding. So for example, here's one toy network in which we have a context layer, we have during the retrieval, you activate the list context, which spreads activation to items. So it's possible that deep semantic processing selectively boosts item memory, but it has no effect on item context bindings, and that actually intent to remember is required to boost item context bindings. So that would explain why within subject experiments we see better memory for the remember items, but why is it the case that in mixed lists this doesn't have an effect? When one possibility is that people in the incidental learning group can actually lower their retrieval threshold. Oh, can you still see me? Okay, something blinked out. People in the incidental learning group can lower their retrieval threshold to compensate for the weaker memory traces and output more items. They can't do that within subject experiments, however, because all of the items are intermixed in memory, and a single retrieval threshold must be used. Just as an example of how that might occur, so here again we have this toy network. In a mixed list, we have weak and strong bindings indicated by the shade of the gray. And then when we spread activation from the context, the remember items are activated much more highly. Here on the bottom, we have activation strength, and a single retrieval threshold must be set, which leads to retrieval of more intentionally studied item and very few incidentally studied items. In the incidental learning group, the activation memory and the memory strength distribution is exactly the same, but since we don't have an intentional learning distribution, people can shift that threshold, which even though would lead to more memory for incidentally studied item, as you can see, it would also have the negative downside that you would have more intrusions from long-term memory of words that you haven't studied on the list. And this is one of the predictions of this count that we'll test in the subsequent experiments. So, to test this count, we have 3 experiments. First, I mentioned that deep processing might be sufficient to boost item memory specifically. And if that's true, if we change the free recall test to an item recognition test as a surprise at the end, we should see very little difference in memory between the intentionally and incidentally learned item. Then I already mentioned that if people are lowering the retrieval threshold in the incidental learning group, we should see more extra list intrusions for incidental learned items in between subject experiments. So here we perform the replication of between subject experiment, keeping all other procedural details exactly the same as our within subject experiments. And final experiment test changed the memory task to a source memory task, in which people see words on different locations on the screen, and then they have to retrieve the location. In this type of task, thresholds aren't involved, so we should see an effect in both between and within subject designs. So when it comes to the item recognition task, what we find, item recognition for process only and remember items is almost at ceiling. We do have a little bit of a difference of about 3 to 4%, but overall, in contrast to the free recall results where process only items are at floor, we actually now see memory at ceiling for item recognition. So it seems that deep processing is sufficient to encode the items, but possibly not the item context associations. So when it comes to between subject experiments, so the design is exactly the same as within the subject experiments. We still have color cues in order to maintain that similarity, but people were told to ignore the colors, and one group was told that there would be memory tests, and the other group had a surprise memory test after list 3. Just like all previous between subject experiments, we find that there's no difference in memory between the intentional and incidental learning group. But now the key question is, if we look at incorrect responses on the list 3, and we see how many of them come from incorrectly recalling items from list 1 and 2. If people are lowering that threshold, we should see more intrusions in the process-only group. Oh, and by the way, we still see difference in encoding reaction times, as I mentioned. Okay, this is indeed exactly what we find. We find twice as many intrusions in list 3 in the process group relative to the remember group. We've also replicated that by reanalyzing one experiment from Oberauer and Greve, in which they had 5 different lists of words. And here I'm plotting on list 5, if a word was recalled, what list was it studied on? So for the remember group, almost all items came from the correct list 5. In the incidental and forget group, even though they recalled the same number of items from list 5, they incorrectly retrieved 2 items from each of the preceding 4 lists, suggesting that indeed we see many more intrusions because of the lowered thresholds. And finally, in experiment 10, as I mentioned, we presented words in 1 of 4 locations. People again had to do the semantic judgment task, and they would see red or a blue border afterwards. And then as a test, they would see the word on the top, and then they have to select which of the 4 quadrants it appeared on. Here, they directly have to retrieve the binding. Thresholds aren't involved in this type of task. And again, we had a between subject condition and a within subject condition, this time all in one experiment. When it comes to free recall, which people did before the source memory test, we replicated this dissociation with an effect of intent in mixed lists, but not in pure lists. But now suddenly on the source memory task, we see that intent has an effect both in mixed lists as well as pure lists, suggesting that indeed the item location binding was weaker in both of these types of groups. So now with this, we demonstrate that this dissociation is only true for free recall, but not for source memory, consistent with the idea that intent affects memory in all conditions, but it's something about the retrieval process in a particular item is the lowering of retrieval thresholds that leads to equivalent memory in this condition. No, I had one more slide with summary, but I guess that will suffice as well. In contrast to decades established long claim, we think that intent has a substantial effect on episodic memory, and that effect can be masked in pure lists because people can lower their threshold. If you want to learn more about this, we have this online, and thank you for the attention.
Thank you very much, Ven. Very interesting talk. So we can open up the floor for questions. Hannah?
Oh no, this wasn't a question. This is just applause.
Oh, okay. All right. Oh, yeah. Sorry. I think Jeff has his mic unmuted.
I do have my mic unmuted, and I do have a question. I was just waiting for somebody else to have a go. Okay, I'll have a question, and it's to do with whether participants, when you have a within subject design of a 30 list item, I assume, I'm sorry, I haven't read the preprint, but I'm assuming there are like 15 items to remember and 15 items that you're not told to encode or it intends to be tested on. I'm just wondering to what extent you've kind of ruled out a selective rehearsal explanation in which you might selectively rehearse the items for which you think you're going to be tested on. I noticed that when you have a within subjects, design recall is a bit better. So it might be effectively having a 15 item list for recall rather than a 30 item list when you're trying to do the whole list. So I'd be interested in looking at, for example, serial position curves. Do you have a primacy gradient going across a primacy effect on the free recall of intended items, but not those you're not intending to learn? I mean, I suspect it's something you try to rule out in one of the experiments you didn't tell us about.
Yes, so there are 2 parts to that question, right? So when it comes to serial position curves, yes, there's a primacy gradient over remembered items. But also if we look at the between subject experiments where people remember the exact same information between intentional and incidental learning, we see a much stronger primacy effect in the intentional learning group and almost no primacy and primarily recency in the incidental learning group, suggesting that people are indeed doing something different between those two conditions that shifts the effect from primacy to recency. Now, when it comes to selective recursal, no, that's not an explanation that I have excluded per se, and I think that might be playing a kind of a role, but it's, so basically what we've learned so far is that intent does something on top of deep processing. What that something is, we cannot exactly say. It might be selective recursal. It might be something else. People might be engaging in more active imagery or creating stories or something like that. So we don't know what that is, but in any case, the main conclusion stands that intent does cause some additional processing on top of the previous findings in between subject experiments. Yeah.
Okay, yeah, that seems fine to me. I don't know whether you're aware of a paper a few years ago by, I think it was Jean Brewer, on free recall and value judgments. I can send you the reference. Basically, you present participants with lists of items for free recall, and you give each item a value, and you get points for the value of each item. Then he's shown quite nicely that participants effectively do something a little bit like selective rehearsal. In fact, I think he has an overt rehearsal experiment in there, and that's exactly what they do. So that's one thing. And are you aware of the kind of item order, Deloche and McDaniel, where you're mixing up? Yes. So yeah, that's fine. But really interesting. I'll enjoy looking at that preprint and maybe get back to you later.
Yeah, so selective recursal is one possible explanation. I personally don't think it's that. So for example, in one of our previous paper, we looked at similar item-wise direct forgetting paradigm in which you're told either to remember or forget an item. And in that paradigm, I showed that your memory for one item is worse if the preceding item was to be remembered, suggesting that you engage some kind of a limited resource that then is not available for the subsequent item. But importantly, that happened even if we suppress recursal as well. So even though that's a different different experiment, I would bet that we'll see similar effects even if we suppress recursal here.
Yeah. Okay. And I have to confess that I use the term rehearsal rather behaviorally, so that when I do overt rehearsal experiments, I'm assuming that participants are using quite a wide range of different psychological processes, and they're saying out loud what they're thinking about, but it might not be strictly always, there might be, but not always articulatory rehearsal. They might be imaging or any of these other elaboratively encoding tasks, but they're referring to the thing that they're currently thinking of. So yeah, I'm happy with that. Very interesting.
Okay, so I think maybe I'll have a go if there are no other questions. So I have a similar question about relational encoding. So I think you mentioned somewhere that on the process trials that follow remember trials, they get an additional RT. And you thought that that had to do with prolonged processing of the previous trial. But if they're in a relational sort of encoding mode, maybe that extends to the next one somehow. And if so, you should see that in the performance of the process trials that follow the remember trials. So you could rule that out as well, the persistent, relational encoding state.
Yeah, so we had it here in one experiment. We changed the semantic judgment task. Rather than having people judge the word relative to a fixed referent, we had them judge every word relative to the preceding word. So we would see tree, car, something, and when you see car, you have to see whether it's smaller or larger than a tree. So in that paradigm, first you make two judgments basically for each word, once relative to the previous item and then the next item relative to it. But this way you're also inducing relational encoding of all items regardless whether they are remember or process only. And so in that experiment we find exactly the same effect, massive effect of intent, even though people are very accurate at making these relational judgments. So yeah, even though they're
Yeah, I meant more in the sort of a storytelling thing that Jeff mentioned, right? Because we do know if we ask people about their strategies, especially when you ask them, questions about how they encode word pairs and relate them to each other in those kinds of paradigms, they typically engage in this storytelling sort of mode. So I was just wondering how you discounted that as an explanation.
So this is just an analysis that I did yesterday because one of our reviewers of this paper mentioned that as well. So in the final experiment only, we also asked people to report a strategy they had in a free-form text. So we have about 100 participants, and I called it these strategies. We have a nice distribution. About a quarter of people use rote repetition. They said they just kept saying the words out loud until they filled their buffer and then moved on. We had some people create stories. Most try to use some kind of imagery. And if I split the results by these groups, it doesn't make a difference. So we see the same difference between process only and remember items of the same size, regardless of whether people engaged in story, imagery, or rote repetition. So this is just a preliminary analysis. I'm not exactly sure what to make out of it, but I think on the surface, at least, it seems that it doesn't matter exactly what people are doing, just as long as they're doing something additional to the remember items.
Okay, cool, thanks. I think we'll take one more question from Deborah.
Hi, Ben. Really, really interesting talk, and I look forward to reading your preprint. The question that you were asking is one that has troubled me for a number of years in my research on the effect of emotion on free recall, where I kept seeing the same pattern of a mixed list advantage for multiple items, but there was no difference when the lists were blocked. We then extended the same paradigm and saw that for reward. So similar to the paper that Jeff mentioned, where people are rewarded for more money for remembering some items and not others. So it looks like there's a really ubiquitous list composition effect for any item that you have a reason to elaborate on, regardless of what that reason is. Now, you did mention item context binding effects, but that wasn't a model that you used. I found it very useful to account for list composition effects because it just the finding that you describe where there's only an advantage in mixed lists just falls out of that model, because if there's competition at retrieval and all items are strongly bound to their context, then you don't get any advantage in the pure released results, and it's something that's very easy to model. So could you say a little bit more why you discounted these kind of explanations for your data?
Sorry, I was following you until the end, but...
so you said something about reduced retrieval thresholds, but if you use something like temporal context models, more generally, they apply really nicely to exactly your kind of data, and they predict these data exactly. So why not use them to explain the effect?
So maybe I'm not understanding the distinction, but I think in general, the explanation is very similar. If you are asking why I haven't applied the TCM model particularly to this, it's mainly for simplicity. I think it would be useful to actually model this data at some point, but I think the general conclusions stem from the behavioral findings.
Yeah. Well. I don't object to the general conclusion. I was just wondering if there's anything in your data that challenges the explanation that TCM models would give. Like, are you offering an alternative to those models and explanations?
I have to think more about it, whether there's a fundamental distinction. As I said, most of these assumptions are based on both the TCM model and my and Lynn Ritter's SAC model, particularly the combination that stronger versus weaker bindings apply in both lists, but only in the between subject lists you can lower that retrieval thresholds. But the other point that I wanted to take up, so just as you mentioned, and I mentioned in the beginning, so there are ubiquitous examples of list composition effects. So maybe one would want to think of, can we provide a comprehensive explanation of list composition effects? Not only that gets a little tricky. So for example, if we take something like the word frequency list composition effects, is kind of exactly the opposite of what we find with intent here. you typically get effects of word frequency in pure lists, but not in mixed lists together. So even though it would be very appealing to try to explain list composition effects with a single framework, I think we need to be a little bit cautious about that.
Okay, thank you, Ven.